Today, there are three main types of treatment to fight cancer: surgery, chemotherapy, and radiotherapy. Unlike traditional radiotherapy that uses photons to irradiate and kill tumor cells, proton therapy is an advanced form of treatment using protons. These particles give proton therapy its many advantages. Proton therapy's greatest advantage over conventional radiation therapy is its accuracy and its ability to spare healthy tissues. Conventional X-rays are made of photons that pass through the body and deposit considerable energy before and after the tumor. Protons, however, have a particular physical property called the Bragg peak. They're able to deposit less energy on their way to the tumor and do not affect tissues beyond it. This property allows to confine the radiation dose to the tumor and radically decreases the risk of injury to surrounding healthy tissues. The proton originates from the iron source, where hydrogen atoms are separated into electrons and protons. The protons are injected into the cyclotron, where they're accelerated. Then, these high-power protons are sent through an energy selection system and a degrader that adjust their energy. The beam transport system conducts the protons with the right energy and trajectory. Then the proton beam arrives in the treatment room via a gantry. The gantry revolves 360 degrees around the patient so that the beam can be delivered at any angle. A high accuracy of patient positioning is required. IBA's treatment rooms are equipped with the latest patient positioners, alignment, and imaging systems to ensure the reproducibility of patient positioning. Today, proton therapy patients have access to a state-of-the-art delivery mode called pencil beam scanning. The beam is steered across the target volume one layer at a time, pixel by pixel, to precisely match the shape of the tumor. With this active scanning technique, the physicians are able to change the proton dose at any specific location in the target. This allows proton therapy to adapt to very complex shaped or moving tumors, improves the dose conformity, and reduces the integral dose of radiation given to the patient. Proton therapy is changing the way you treat cancer.
Hi, good evening, good afternoon, or good morning, depending on where you have logged in. And we have delegates from all across the world, right from Latin America to South Asia and India. Thank you all for sparing your valuable time and getting yourself engaged in this fifth ISOP, International Society of Proton Therapy, a series of webinars which IBA, the global leader in proton therapy, is conducting. In this preamble, I will be giving you a small brief on the event, and also I have the proud privilege of introducing the distinguished speakers in this webinar. IBA, which has a dominant share in proton therapy, is engaged in disseminating proton therapy knowledge, clinical applications, technology updates, etc. And this is the fifth of the series of webinar or the conference in the form of a webinar due to COVID. There are two such events which is going to happen, one today and one on 21st, exactly a week after this. In today's program, we have a distinguished national global luminary, Dr. Siddharth Laskar from Tata Memorial Hospital, Bombay. He heads the position as a Deputy Director as Academics and is also the Professor of Radiation Oncology in TMH. He has a wide range of experience in for radiation oncology and management of cancer across pediatrics and a host of clinical applications, including soft tissues, bone, and quite a variety of clinical applications. He also has special interests in interstitial brachytherapy and other radiation modalities, which gives him a wide exposure to the field of oncology. As most of you must be knowing, TMH is the prima donna cancer institute in the country and caters to a huge population of cancer patients. And Dr. Laskar is driving this oncology program there. In this module today, Dr. Laskar, who also heads the Hadron Center, the ACTRACT facility where the proton therapy is going to be launched, and it will probably go live next year. And he will be covering on a very important topic on the need, the challenges, and the opportunities in and the way forward with proton therapy in TMH. And I will also like to introduce the next speaker after this, my colleague, Dr. Claude Dupont, who is a doctorate in physics and a lifetimer in IBA. And he's been serving IBA from 1986, almost 34 years, and donned various roles. And he was involved in various big deals, sign up, including MassGen and a host of Proton deals in Europe and the famous Apollo and Tata Memorial in India. Without much ado, I would like to pass on this mic to Dr. Siddharth Laskar. And one small housekeeping, there is a chat window for the participants who have clarifications or questions. You could type it in, and all the questions will be addressed towards the end of the sessions. Over to Dr. Laskar. Thank you very much, Laskar, for accepting to do this. Thank you.
So good evening, everyone across the globe. Good afternoon, good morning, wherever you are. Thank you very much, Sri, for the kind introduction. Thank you, my friend Rakesh. Thank you, Claude. And thank you, Team IBA, for organizing this webinar and for inviting me to share my experience with the Proton Therapy Center at Tata Memorial Hospital or Tata Memorial Center. We haven't yet gone clinical, but I would love to share how we started off, what was the need, what were the challenges, and as we stand, what are the opportunities that we have in the future with Proton Therapy Center starting at the Tata Memorial Center. So let me start off with the need. But before I go into the need for Proton Therapy Center in India, and especially in Tata Memorial Hospital, to make it more relevant, one needs to understand and go back a little bit and look at the lineage and the history of Tata Memorial Hospital, and that would make it more relevant for one to understand why Proton Therapy Center at Tata Memorial Hospital is so relevant and so important. As you know, many of you would know that this hospital was inaugurated and established in 1941, in February 1941, by the House of Tatas at that point in time. And that was after the family felt the need of having a state-of-the-art cancer facility in the country that could serve the entire nation and the needy who did not have that kind of a facility at that point in time. As you can see in this picture, that was Tata Memorial Hospital in 1941, and that was associated with an 11-page supplement in the famous Times of India dealing with Tata Memorial Hospital. And what the caption was, "How Hospital Will Fight Cancer in India." So we should also know who were the creators of this institution. Obviously, this was the House of Tatas. And I want you to read these two quotes. The first by Sir Robert Lumley at the inauguration of the Tata Memorial Hospital. And what he said was, the name of Tata is known throughout the world as a house of great industrialists and as a family of great philanthropists. But of all the philanthropic projects connected with the name, none would attain a greater importance or reflect greater credit on its founders than the Tata Memorial Hospital for Cancer. This hospital is the first large contribution of India to the international fight against cancer. And the other quote is by Mr. J.R.D. Tata himself. And he says, if I were to attribute any single reason to such success as I have achieved, I would say that success would not have been possible without a sustained belief that what I did or attempted to do would serve the needs and interests of our country and our people, and that I was a trustee of such interests. So that sets the ball rolling, and that sets the theme of why Tata Memorial Hospital and Proton Therapy Center in India in Tata Memorial Center is so important and so relevant. India, as you know, is a large country with a population of 1.3 billion. We have 14 languages and we have a life expectancy of 65 years now. And a large proportion of our population still live in the rural areas. The literacy rate is about 60%, and we still have a problem with infant mortality and infectious diseases. And in our country, we have almost about 1 million new cancer patients a year. So is cancer the real problem? Or do we need to put in all the money in cancer care? Do we have the people who can spend that money? Where should we spend that money if there is something so expensive? But the lower part of the picture shows you we have a very, very varied population. And you can see the differences in economies that we have. We have the very rich ones who could probably buy off countries. At the same time, within a few kilometers, you would have people who would struggle to have a meal in a day. So there is a whole range of people that we need to cater in this country, and a large population within the country. And that brings up the question of the need for an expensive treatment modality like proton therapy. So if you look at this map here, this was a couple of years old, and you can see the number of patients that come to the hospital. A couple of years back, about 62,000 cancer patients came to Tata Memorial Hospital from across the country and abroad and the neighboring countries. Now it has gone up to almost 80,000 cancer patients coming to the Tata Memorial Hospital. And we do realize the need to decentralize our operations. And we do realize the need to develop centers of excellence in line with the motto of Tata Memorial Hospital across the country to make quality cancer care available across the country to everyone who would need them. And that is the reason the Department of Atomic Energy of Government of India has decided to set up these multiple centers across the country to cater to the needs of cancer care across the country. We also have developed the National Cancer Grid, primarily with the objective of patient care or uniform patient care across the country, to adapt evidence-based management guidelines across the country, to peer review one another, and to improve the quality of cancer care across the country. Besides that, the aim of the National Cancer Grid also is to educate and train manpower. And of course, research is a big focus for the Tata Memorial Center. Right now, we have 185 centers across the country networked, and we last year also launched the NCD Vishwam. It was launched in Vienna at the IAEA by our chairman, and this incorporates various centers out within the National Cancer Grid network. Now, there is a very relevant reason why I'm telling you about the National Cancer Grid and the multiple centers that are networked to Tata Memorial Center and its implication on proton therapy. So just take you through, we have finished 75 years of service in 2016, and we celebrated that with multiple academic meetings. And as I take you through, in 1941, we established, we had the Cancer Research Institute in 52. Then the administrative control of Tata Memorial Hospital was transferred to the Department of Atomic Energy, Government of India. So we became a government organization. And then we developed ACTRAC, where Proton would be located in 2002. It was inaugurated in 2002, and in 2005, the Cancer Research Center, Clinical Research Center, was inaugurated. And now, very soon, we would be going clinical with the Proton Therapy Center and also a center for solid tumors, including a specialized treatment center for children and also hematolymphoid malignancies. So that is where we are going in the future. So what are we trying to do? We are basically trying to deliver affordable cancer care, quality cancer care across the country. Here are some statistics for you. We are a developing nation. If you compare the amount of money that we would spend per person in cancer care in India, is about $10 US, whereas in the United States, you would spend almost about $100 to $110 US per person. That's a huge difference. And the other difference between India and the other developed countries is the health insurance coverage. So not many people have health insurance coverage in India, and thus it makes it very difficult for expensive cancer care to be made available to the general population. There have been multiple initiatives by the government, and the latest one is the Ayushman Bharat, which is the PM, which is also popularly known as the PMJ healthcare foundation, and that caters to almost about 50 crore citizens across the country. That's a huge initiative taken by the government, and hopefully soon it will be very effective in delivering cancer care and general health care to the citizens of our country. So coming to more focused, radiation therapy in Tata Memorial Hospital. These are pictures of radiation therapy that we had at that time in 1941 when we started. That's a picture of contact therapy being done. And on the right-hand side of the screen, you have the radium brachytherapy being done at the Tata Memorial Hospital. We were also privileged to have the Janus machine, which was an indigenously developed teletherapy machine. So we have a history of indigenization and developing machines and equipment in our own country. So we have come a long way in radiation therapy at the Tata Memorial. We had a whole range of equipment, starting from the cobalt machine to cesium machine to the linear accelerators, single energy, to IMRT, to tomotherapy, to image-guided therapy, and now we have proton therapy, and we are also planning to have heavy ion therapy in the near future. We are extremely strong in brachytherapy in our department at TMC. So within the Mumbai facility, we get referred almost about 13,000 patients for radiation therapy. We currently have 5 cobalt, 6 linacs, 2 tomos, and we have a 3 gantry proton therapy that should be functional next year. And we end up treating almost about 8,500 patients every year. And so you can understand the patient numbers that we have who are referred for radiation therapy. A little bit about history of particle therapy. And again, we have come a long way in the accelerator technology from the time it was first started at the Berkeley lab in 1939. And again, the first clinical use of proton therapy that was suggested in 1946, and the first hospital-based proton therapy center that came up in Loma Linda in 1990s. So we have come a long way from there, And as we have seen proton therapy moving from then to now, we have understood various physical and biological advantages of protons. I probably don't need to really elaborate deep to this audience, but what we know is that because of the physical properties of protons and heavy ions, we are able to spare normal tissues better. And there seems to be some kind of biological uh, uh, advantages of proton therapies also that needs to be defined. And because of these advantages, both physical and biological, there are clinical implications for us clinicians. The improved conformity reduces target doses, so obviously toxicities would be expected to reduce. We would be able to escalate doses of radiation in resistant tumors. We would be able to combine chemotherapy and surgery with radiation therapy. We will be able to hypofractionate radiation and deliver the same doses in a lesser duration of time. It could be useful for re-radiation, and probably that would end up in an improved therapeutic ratio in the future for many tumors that we end up treating. Reduction in toxicity is probably one of the biggest advantage of proton beam therapy and carbon ion or heavy ion therapy. And of course, of late, we have been all looking at the biological efficacy, improved cell kill, and the latest kid on the block is the immune modulation done by particle therapy. So these are the basic advantages or clinical implications of particle therapy. But do we have clinical data on a robust clinical data? Unfortunately, although we have been using proton therapy for a long, long time, we still do not have robust clinical data to say that proton therapy actually scores over conventional in some tumors. But there is new data coming in. There is some data coming in which shows that there is benefit of proton therapy, especially in pediatric tumors. And I happen to be part of this group of people who sat down and had a consensus meeting in Stockholm about 5 years back. And as you can see, most of the participants here voted that proton therapies probably would have a significant impact, especially in pediatric tumors. And that is one of the reasons why all pediatric centers are looking at proton therapy as one of the technologies that they would want to have. So although proton therapy has been there for a long, long time, it has been located in pockets. Most of the centers with proton therapy would be in the United States or in certain areas of Asia like Japan, China, Korea. And fortunately for us in India, we didn't have it a few years back, but now we have two centers, both IBA. So thank you, IBA, for coming into India. And we hope to be doing a lot of work and also would try to plug in a lot of deficiencies that are had in both in terms of the physical parameters and also clinical data that we need to generate for the use of optimal use of proton therapy. So definitely there is a need to have proton therapy in India because of the number of patients that are there, the expertise that is available, the cost of treatment if a patient has to take treatment abroad now. So there is definitely a need for proton therapy to come to India. But what are the challenges if you have to have proton therapy in India? Yes, the first and most important thing is to have the money. And in Tata Memorial Center, we are fortunate to be a part of the Department of Atomic Energy. And as you know, the Department of Atomic Energy lays a lot of emphasis on healthcare, and oncology is one of the main focuses of the Department of Atomic Energy. And we have always been at the forefront of research and education and service. So we got the money from the government of India, the Department of Atomic Energy. But once we got the money, then it came to us, and our responsibility now was to be able to identify the best system that we could get for our center. So there came my role, and as unfortunately, we did not have set technical parameters available like we have for Linux or Cobalt machines. So I looked up literature and I was struggling to find out what specifications about the accelerator, the machine that I could look into from somewhere. But this was the only thing that I could get, which was published in 1993. It was pretty old, but I did manage to get some parameters, technical parameters, to roll out our technical bid internationally for companies to bid for the system. And this is some data which you all know, and this is where I started off from. We also needed to know what are the clinical specifications that we would be interested in, and I got some data from the same article. But mind you, I have not changed this slide. I did not put the IBA cyclotron there. It was my slide that I made at that time, and I did not change it. And it is just a coincidence that finally we have IBA as our partner in this Proton facility. So it was IBA at that time. It was just a coincidental thing. So I did go through all these. The other challenge was to know whether we should have a gantry or a fixed beam, whether we should have a single gantry or multiple gantries, whether we should have 270 degrees or 360 degree gantries, whether we should have scanning or scattering, what beam specifications we should look at, couch specifications, imaging and gating, treatment planning system, rolling floor versus no rolling floor. I'll tell you a story about that later on. And of course, calculation of uptime, downtime, and so many other factors were there for me to really sort out. So where did I get this information? And I was really fortunate to have IBA and even other companies who really came forward and gave us parameters that they had. And besides that, I was actually fortunate to be doing pediatric oncology, and many of my friends across the globe were doing pediatric oncology and protons, and that's where I got the information and some of the answers that I needed before we finalized the technical specifications for the global tender. So we floated our global tender in 2015, and we finally signed the contract with IBA. And now I know that we did sign up with the best company at that time and even now. And I think that was a very good thing that could happen to us. Here is the team. You can see Rakesh Pathak. Probably he had slightly more hair at that point in time. And I also had slightly less of gray hair at that point in time. We had the privilege of having a very active joint controller of finance, Indira. She's left us now, but she was a great help. And of course, Sabine was there always to help us. So thank you, Sabine, if you're listening to us. And that started the partnership. After we signed up with IBA, we wanted to know how to go ahead. We had to build this partnership. We had to foster a relationship, and with a primary goal of fighting cancer and getting quality cancer care and getting quality cancer treatment in our country, in the government sector, which was most important for us. So we did visit IBA in Belgium, and it was very nice to have Olivier, and that's Olivier with Dr. Badouet, our director of TMC at the IBA office in Belgium. We did have the privilege of visiting and seeing a cyclotron for the first time, and that gave me an insight into what is actually required. I also had the privilege of meeting Yves Jongen, and he was a true inspiration. It was a fantastic meeting that I had with him, and I still remember telling him that of our facility would be to deliver or to give quality cancer care free of cost. And he almost had tears in his eyes, and he said, that is what IBA looks at, and that is what IBA wants, and we are with you in this journey to deliver quality care to patients in your country and elsewhere at a very, very affordable cost. You can see rest of my friends also there. And at the same time, I learned other things also. I love technology, and that is Olivier's Tesla, which I had the privilege of driving out and checking out in the highway. So thank you, Olivier, for that too. And we did have a taste of the Belgian chocolate. How could you do without it? So that started the journey in 2015. What I learned from that trip was the culture that IBA has, the systems in which they work. So it was fantastic. It is very, very encouraging for me at that point in time as this journey was starting. So, finally, we decided to have this facility at ACTREC, that is the Advanced Center for Treatment, Research and Education in Cancer, which is located almost 30 kilometers from Parel. And that's the picture of ACTREC, a bird's eye view. And it's bustling with activity now. ACTREC, we have the clinical research sector, the Cancer Research Institute, which is the biology part. We have the Center for Cancer Epidemiology there. We have the Proton Therapy Center. We'll have the HEMAT and Pediatric Unit. We have a Radiation Research Unit and also a Phase 1 clinical trials facility. And that's where our Hadron facility or the Proton facility is located. And hopefully later on, we may have the heavy ion facility just next to the Proton facility. So that's the location where we decided to have it. But then started the struggle. Then started the challenge. First, we needed to understand, we needed to read the IBD document. It was the first time in the country that we had a proton therapy center coming up. And we had multiple stakeholders. We had our construction guys. We had our architects who needed to understand. It was a complex building with a complex design. So that took us a lot of time, a lot of discussions. And I have to tell that there was a great help from IBA. We used to have weekly, and still have meetings very frequently. We used to have weekly go-to meetings to explain to our architects, to explain to our engineers what a particular thing meant. And that was so crucial in achieving what we have achieved as of now. So after all that discussion, we did come up with the design for the Hadron area. And of course, we have a fantastic support facility that also houses the clinics, the patient clinics, a nice lobby here for the general and the private patients. We are also having a CT simulator. We're going to have a dual energy CT simulator dedicated for the Proton Therapy Center, and also a MR simulator for us, for our facility dedicated to the proton therapy facility. We also have a space dedicated to radiation biology lab, because we would be doing a lot of research and development activities also. So there is an attached dedicated radiation biology lab associated with the Proton Therapy Center. We propose to work day and night, and there is an area just behind the gantries where we propose to have a basketball court, and I have promised that the basketball court will be open after 12 o'clock in the night till 2 o'clock in the night. So the people who are working there can actually work and have some fun in the evening too. So that was the design, and that was the architect's rendering of the proton therapy facility. That's the gantry area. This is the clinical area. And you will see towards the end of my lecture what it looks like now. We finally began our work, the groundbreaking, in January 2018, after we got our civil contractors on board. And that is me breaking the coconut, which is supposed to be auspicious. And that's the first day on January, that's 22nd of January that we started work. And that's the team that was there with me on site on that particular day. And there has been no looking back after that. So that is what the area looked like immediately after we started work. There were two specific areas, the Hadron or the Proton area and the support facility. Very soon we had a structure like this. I did not realize how complicated, and neither did our architects and our engineers or the civil contractors understand how difficult it would be to do these things. And why was it so difficult? It was so difficult because these are complex pipes, the conduits, they have to be very accurately placed in a particular manner. The thicknesses have to be accurate. And at the same time, you need to do your construction maintaining quality and also maintaining timelines. So it was a huge challenge for us to all come on board. And it was very difficult in the first few months for us to be on the same page. One would understand and one would not understand. The meaning of something would be different. And all the way, both Rakesh, Carlos, I remember IBA has been fantastically supportive in these things. And whenever we needed to, and some explanations, they were always there to tell us what it actually meant. So as I said, we had timelines, and I know IBA works with specific timelines and specific activities by those timelines. We tried to emulate some of them, but it was very difficult for us to really do it that way because of multiple constraints that we have in the country, and some of which we do not envisage, some of which we know. But we did have timelines, we did have PERT charts to try and see if we can coordinate activities as we went on with the project. So almost 13 months, we were almost like this. We had the gantries, the rooms more or less looking, they were building up, and the cyclotron area you can see there. So we were doing pretty well. Another thing that we had done, this was something new that we did, and that was by intent, was that a part of the machine would have to be manufactured in the country. Many companies actually backed out listening to this demand of ours, or requirement of ours for that matter. But thanks to IBA again, IBA said, yes, we would take the challenge. And there we tied up with an agency, and that was all IBA's work. And that's me visiting the site to see manufacturing being done. And again, thanks to IBA for the quality of product and for making it possible to do it in India too, which is a major focus for our government currently. We had to meet timelines. Construction was going, but in Mumbai, once the rain started, it was difficult. So we had to stick to timelines. We had to work in the night. We had to push people to work in the night. We had to convince people to understand the importance of working in the night and also during the rains. But keeping the pack together was important. Keeping them motivated was important. But I think it was a wonderful place to work in. As you can see, the beautiful place to work in. And we did manage to go along together very productively. And thanks to Rakesh and IBA, again, we had timely inputs and critical inputs coming in at very critical times, what to do, what not to do, what needs to go faster. And also, Rakesh was good enough to show me certain things that need to be done in a particular way, which may not be directly related to the Proton facility, for me to be able to understand the significance of a particular thing. Here we are standing below a bridge where he showed me why it is important to do a particular construction in a particular way. And this is a bridge that probably he was associated in building. We were also we were very particular about choosing the right furniture, and here you can see choosing furniture. And this is actually the furniture which is there in the IBA room right now, where the physicist would sit. The first equipment came, and we were very, very excited. This was the UPS, and you can see the joy in everybody's face, all the workers and all of us. But there were unexpected challenges also. We had to do some reroutings, we had to make some modifications, and that did have an impact on time. And again, thanks for the collaborative efforts of IBA and with us and the engineers, that we were able to overcome these unexpected challenges in a way that we would not lose time too much. Then came the heart of the system coming in, and I had the privilege again of receiving the cyclotron that was shipped from Belgium. And it was what a pleasure, and you can see the joy in everybody's faces, the engineers, and we were there at the dockyard to receive it, and then the administration, everybody, the physicists, the engineers, all of them being there to receive it with all joy. It is again very important and very critical to have the right people on board. And this is a picture. This is a golf cart at Actrec. You can see the cabin behind. And I can tell you, the one who is doing a thumbs up is the chief security officer of Actrec, who's driving us around in this cart. The man smiling next to me is the CAO, the chief administrative officer. On my right is the joint controller of finance, and on the right of him is the chief of physics. So we had to keep everybody on board. They are the critical people who would drive this facility. And again, we were privileged to have very quality, dedicated people with us, brought to the site at the vital times when we needed them, and that made so much of a difference. And again, I have to name Rakesh for giving us the vital feedbacks, the good or bad feedbacks to the right people at the right time. And there you can see Rakesh, Navid, and Carlos with Dr. Budway, who's the director of TMC. Jan 2020 with the cyclotron rigging, and I am told that was done in record time. And this is the first time that I realized what puja can do. Puja is done in India. It's a very important thing. And thanks to Rakesh again and IBA, we had a wonderful puja to bring in the cyclotron to our facility. And you can see the joy of the entire team there. You can see Navid, Benoit, and Rakesh. You can see the sleepy eyes, but the joy in their faces when the cyclotron was rigged in January 2020. I'm told this is again close to a record time that we were able to rig the cyclotron. I have to mention the continuous support of my friend Thierry. He's been tremendous, and he's always given me very vital inputs on what to do, when you can expect something, how to do, and how to be prepared for everything. And he did make it to this function, although he was in a very tight schedule. He came for a day. And thank you, Thierry. I know you're hearing me. Thank you very much for being with me, being with us, and being for what you have been to the Tata Memorial Center Proton facility. We also had tremendous support from the TMC, the Tata Memorial Center Administration, and the Department of Atomic Energy. Here you can see all the directors of the center alongside me. And we also have the director of the Bhabha Atomic Research Center in this picture. So we had tremendous support, and you can see the Consul General of Belgium also gracing the occasion. And you can see it's very aptly written, on our way to change the way we treat cancer. And that's the cyclotron hidden behind it. So that joy was not too long-lived, and we had to get down to business. And that was because it's January, and in June, the monsoon started in Mumbai, and the rains, once the rains start, you could damage the equipment. So we had to close the hatches. So that was a very, very difficult time for us. And very soon we had the corona virus, the COVID-19 coming, and you can see the change in us. We are all wearing masks now. We are all masked. And despite that, I have to really congratulate again Team IBA and helping us how to move ahead even during those times. Because if we did not do that, we would possibly lose about 6 to 7 months of time, of vital time. We would lose out on patient treatment. And of course, there was a possibility that we could damage the equipment too. But with the support, with the intent, with the grit, we went ahead and we very successfully closed the hatch. And you can again see our directors with myself. We are standing on the roof, closing the hatch. And that's the gantry once it came into the room. We had wonderful times. We have not only remained as professional colleagues, but it's like a family for me now. We celebrated a birthday party for me. It was a surprise party. It was a fantastic surprise party done. And finally now the latest is that despite the difficulties, despite the corona, despite the lockdown and everything, thanks to IBA again for all the support in pushing hard and going ahead with dedication to get the beam-on degrader on time. And that again, I am told, is one of the things that has happened in record time. This is Team IBA with Director TMC, and that's myself with a small replica of the cyclotron of where we have reached. Maybe next time when I do a presentation, we'll have a larger replica, which probably I'll not be able to hold in my hand, because by the time I would have probably finished we would have probably finished the project and we would have commissioned. So that's where we are. So what are the opportunities now? It is huge. This is a massive national significance of this Tata Memorial Center project. In terms of service, almost 30 to 40% of patients receive radiotherapy as a curative intent. And as a thumb rule, we know that almost 10 to 20% of patients receiving radiotherapy would benefit with proton therapy. Now, if you just do a rough calculation in India, beginning 1 million cases of cancer per year, 50% require curative treatment. And finally, if you calculate 10% potentially benefit with protons or heavy ions, that would be about 20,000 patients a year. It's a huge number of patients who would potentially benefit. If I'm slightly conservative, I may bring it down to 15,000, but still 15,000 patients require proton therapy in our country. And in our center, according to estimates, we should be able to treat about 800, but in my guess, thinking that it is Tata Memorial Hospital, I guess that 800 may move up to slightly more than 800, maybe reach even 1,000. The cost implication is huge. If I send somebody to the US for treatment today, it would cost us about 1 to 1.5 crore Indian rupees, which I cannot afford. And what we plan to do in the country, in Tata Memorial Proton Therapy Facility, is that a significant proportion, which would almost amount to 50%, would probably get free treatment in protons. That is the service component, which would be huge. We also have research. We are looking at developing and generating robust scientific evidence to support or refute the use of proton therapy, which is currently not available. We are going to do radiation biology research in a big way. We are going to collaborate. We are already collaborating with various centers. We want to develop patient-specific data. We are looking at immunotherapy in the future. We are also looking at heavy ion particle accelerator technology development with our other DAE institutions. We are looking at data processing and other aspects. And of course, technology, indigenous technology development is going to be a big thing for us in the future. As we have always done, we are going to be the National Center for Training and Research in hadron beam therapy. And we will surely be a big center for human resource development in protons. I will leave you with this last picture of the Proton Therapy Center taken a few days back. It's a fabulous place. It is very green now with the monsoons almost over. It is beautiful. And we are looking forward to a wonderful, wonderful, this is not the end of the journey. This is just the beginning of the journey. I'm looking at a wonderful association with IBA to serve the citizens of this country and to serve the needy and to also do research and education in proton therapy. So thank you very much for your patient hearing, and I would be happy to take questions later on. Thank you very much.
Thank you, Dr. Laskar. It was a very exciting presentation, and we are so motivated to be part of your project. Thank you very much. Good evening, India. Good afternoon, Europe. And good morning, Brazil, because I think we have some guests from Brazil. I am Claude at IBA. I will speak about our contribution in the field of proton therapy. Also, I will explain a bit more about different topics on our roadmap for the future of proton therapy. At this moment, I am sitting right in the middle of our new facility. It was built 2 years ago with an objective of carbon neutral, respective of the environment, That's a place where we assemble the machine, we test before to ship them to the different countries in the world. We are located in the middle of the university campus in Louvain-la-Neuve, 30 kilometers south of Brussels. And I invite you to come when you are around in Belgium. Please pay us a visit. I will be your guide. Dr. Lascar has already explained to us the advantages of protons. The famous Bragg peak, which really demonstrates the fact the proton for a given energy stop at the end of the range of their trajectory. And thanks to their positive and massive characteristic, they stop and spare organ at risk that may be downstream after the Bragg peak. It also allows to save those before the tumor. That's the right part of the curve you can see. Clinically, we already saw and got some flavor by Dr. Lascar. Let me ask you 3 questions. What if you could reduce the amount of heart and esophagus toxicity while treating lung cancer patients? What if you could deliver less radiation to the critical organs of your pediatric patients? What if you could reduce side effects such as coronary artery disease while treating left breast cancer patients? Where do we stand today? Among all the patients who are treated in radiotherapy, it is only 1% who can benefit of proton therapy. While some studies, the Dutch studies, demonstrate that there is a potential up to 20% of that population that could take advantages of proton therapy. And you see over time on the right side of the diapo, the number of patients being treated in green with proton therapy is steeply increasing thanks to the increase of the number of rooms in operation that turn in operation. How IBA is doing? Today, it is 56% of all the patients who receive proton therapy worldwide that are treated on an IBA equipment. This is more than all our competitors combined. I put these 2 patient mix to illustrate the diversity of the type of cancer that can be treated with proton. And like mentioned already before, 20% of these patients can be pediatric, for example, in Beaumont or in Czech Republic in Prague. Let's look at other centers who are equipped with IBA. This is a worldwide map. You see those green dots in the US, in Europe, in Asia, for a total of 59 centers, among which 28 are Proteus 1 and 31 are Proteus Plus. I will describe these 2 products in a minute. And out of them, 36 centers are today in operation, treating patients on a daily basis. This represents a total of 131 rooms sold worldwide. That's an impressive number. Who are behind these green dots I just showed you? I'm happy to share with you this picture taken at the Miami user meeting in 2019, where you can see people from all over the globe with a cumulative experience of 180 years. Among these pictures, some of them participated to the very first patient treatment in Boston in 2001. And since that date, it is not less than 100,000 patients that have been treated on an IBA system. And as a fact, this important milestone has been just reached this month. So we are very, very proud of contributing to that. Now let me give you some flavor on the IBA Proteus Plus and the IBA Proteus One system that we are proposing to the market. On this picture, you can see the accelerator on the upper right corner that is powering and distributing the beam to the different treatment rooms, 2 gantries, 1 fixed beam room, and also a research port at the end left. This configuration corresponds to the Apollo Hospital configuration in Chennai. As far as the Proteus One is concerned, we have invested towards a much more compact configuration. One accelerator is sending the beam to 1 gantry, delivering it to the patient through the nozzle. I have included the Proteus One in that building picture so that you realize the bunker around the accelerator and bunker around the gantry as well. Finally, in real life, this is an example of the first Proteus One effect in Shreveport, Louisiana, where proton therapy bunker is added to an existing facility, just like another modalities in the arsenal of the tools the radio oncologists can use to fight cancer. Okay, it is time now to enter into the Proteus One treatment room. And what you see when you enter in this room, you see the system is open. There is a lot of space around the gantry, around the patient position. You feel also the Philips ambient atmosphere, which is there to cool down the patient, make him quiet, so that the treatment goes as smoothly and faster as possible for the benefit of your daily throughput, I would say. Before you turn on the beam, due to the sharpness of the black peak, you need, of course, to align the patient and the tumor at the isocenter of the room. For that purpose, we have foreseen 2 kV X-ray tube and flat panel, which are fixed, which cross at the isocenter. And on the right, you can see the cone beam CT system that is another tube and another flat panel attached to the gantry, so that when we rotate the gantry, we can accumulate the images that will allow the display of a 3D image of the tissue, giving access to the soft tissue, which are very important for the positioning, of course. Finally, by the use of third-party device, surface imaging is also integrated in the IBA Proteus One to monitor any motion of the patient during immobilization or potentially during the treatment. I come back on the open aspect of the gantry to illustrate the clinical advantage that you are going to have with such a treatment room. In fact, when you see the position of the patient on the picture, you feel immediately that you are going to have access and can deliver treatment for very complex cases such as brain, CNS, head and neck. These are the non-coplanar fields when the patient is not aligned with the rotation axis of the gantry. This is doable only thanks to the openness of the gantry, 220 degrees. Now, I would like to come to the beam because it is time to mention it. And in this video, you will see the pencil beam scanning. Let's wait a minute for the connection. Navin, can you display the video, please? Okay, so we see the narrow beam. We are not talking of a scattering wide beam, but on this one layer has been selected corresponding to one energy. And now we really paint here 2 times a given layer to distribute the maximal dose to the patient. This diapo summarizes the different elements I just explained: ambient experience to decrease patient anxiety, oblique imaging, KV, pure pencil beam scanning, large field of view cone beam CT, remote operation of accessories without entering in the room, wireless and pendant for the comfort of the staff to manipulate the robot, the nozzle, and the accessories, and finally, full open access environment to ease patient setup. This is really a patient-centric, clinically inspired solution. Okay, at this point, I would like to enter into a description of one feature that is at our roadmap at IBA. This is how do we manage motion of the tumor. Why is it important and what is this phenomenon? When you plan the dose before the delivery, if this organ that you have planned is moving during the course of the treatment, the interplay effect will come in and creating hotspot and cold spot. This effect need to be kept under control so that you really deliver what you have planned. How is it frequent? Is it important? We went to the Global Cancer Observatory, and it is not less than 25% of all the patients that could most benefit from proton therapy if we were able to treat mobile tumors. So at IBA, we have defined a comprehensive solution covering all aspects of motion management. We want to be with you when you plan, when to tell you what you see, to show you what you see, to check before to treat. So at the beginning of the planning, you need to decide which technology you are going to use. There are different ones that are available, like breathing technique, gating, breathing hold, gating, or free breathing. We want to offer you maximum flexibility for the benefit of your patient. Also, we want with the Adapt Insight screen, we want to show you the tumor, show you the motion of it, so that you can make the right decision at the right time. Finally, we integrated 4 major devices that allows you to select the treatment methodology, Vision-RT, CIRAD, Anzai belt, or DINER. These different accessories are fully integrated with the IBA Proteus control system so that you can monitor the motion of your patient in full confidence. And finally, we are ready with the beam. You have the nozzle pointed to the tumor, and we will deliver the beam as per the selected process that you have done. I want to insist on the repainting possibility that is offered due to the Bragg peak. There are several methodologies. If you want statistically to avoid hot spot and cold spot, the painting can be done differently. What we are going to show here is painting in 2 steps, so 2 times half the dose. For the first layer, second half of the dose for the first layer, same process for the second and third layer. This is the so-called in-layer repainting. There are other volumetric approach, like delivering half the dose to the 3 layer and coming downstream to deliver the second half of the dose. And finally, you can decide to paint half the dose in the 3 layers and going back to the first one, the second, and the third one. The idea is that supporting the planning phase, see the image of the tumor, the check and the treat, we want to offer you the very right strategy for each patient that you are going to treat. This effort is done in collaboration with 7 major institutions, 4 in the US, 2 in Europe, and Apollo Hospital in Chennai. And this effort led already to the treatment of a lung tumor with pencil beam scanning at the Texas Center for Proton Therapy. So the conclusion is that treating moving target with pencil beam scanning is possible thanks to the latest technology, cone beam CT, automated volumetric repainting, 4D robust optimization, Monte Carlo dose NG, breath hold, and free breathing technique. Okay, I am at the end of my presentation. I already invite you next week, as Sridharan said at the beginning. We will disclose a little bit of flavor on how we are working on the proton arc therapy and also on the flash therapy that can really be a change in paradigm in the radiotherapy world with proton. I thank you very much for your attention. I hope to see you, if I may say, again next week. Thank you for your time.
Thank you, Dr. Lasker and Dr. Claude, for a very enlightening talk on ways of preparing for proton therapy, and Claude on the technology aspects. There are a few questions which have been popped up by the guests, by the attendees. So I will ask each of these questions to the stakeholder, if it's clinically or anything to do with Proton, Dr. Lasker, and then on technology to Claude. Dr. Lasker, this is a question to address to you. Will proton therapy replace traditional radiation therapy?
Well, I don't think proton therapy is going to replace photon or X-ray radiotherapy in the near future. But yes, the indications for proton radiation therapy is being explored, and I think there'll be an expansion in the indications of proton radiotherapy in the near future. But maybe in the long run, as the technology matures, as the technology develops, maybe the application of proton therapy would be more. But I don't think it would replace X-ray radiation therapy at the current moment.
Okay. Thank you, Dr. Lasker. There's one more question to you. When do you expect to start treating patients live with using the proton therapy?
As soon as IBA gives us the center, we will start treating patients. But to be more precise, we are being very optimistic, and I think with the efforts that is being put in, we should be able to go clinical somewhere early next year, which in the first half of next year.
Oh, great. There's a question to Claude. Can single room proton therapy system, the compact one, do the same clinical applications like a multi-room proton system?
Yes, the answer is yes. We made no compromise in terms of pencil beam scanning, in terms of imaging. So the list of tumors that can be treated is really identical for both sides. I have mentioned that non-coplanar tumor would be very appropriate to be treated on the Proteus one due to the openness of the gantry.
Oh, thank you. Thank you. There's one more question to Dr. Lasker. This is more on the patient charges. There are two questions. I'll piggyback both of them. And what are the proposed charges for treatment using proton therapy? And the other piggyback question is, will the proton therapy be affordable to poor patients? So what is the accessibility to poor patients in Tata?
So before I answer the question, Shri, am I visible?
Yeah, very much.
Excellent. So that you can see the expressions on my face as I'm answering that question.
Yeah.
To answer your question, is it going to be affordable and what charges? I will not disclose to you the charges, but I can disclose to you that we propose to treat 50% of our patients free of cost, zero.
Fantastic. Fantastic.
So that is, we propose to do. It'll all depend on how much discounts IBA gives us on a thing. But that's the focus. And that's what I said right in the beginning of my talk, that that is our focus in TMH. And we are going to treat a large number of patients free of cost. So we are going to make very fancy treatments affordable and reachable to the most poorest of the poor patients in the country.
Oh, lovely. Thank you. Thank you, Dr. Lasker. I think we have practically covered questions. I mean, the relevant questions have only been asked here. I think I should thank you, Dr. Lasker, for for accepting and doing this excellent talk, educating people what it takes to get a proton therapy in a country like India with all the technical challenges. And also Dr. Claude Dupont for your nice technological lecture with the futures in proton therapy. I think we are in with proton therapy to really change the landscape of proton cancer management. And I think with this, I think we should close the session. And unless there are any more questions, now we'll just stand by for a few seconds.
I think you can give a reminder for next week, Sridharan.
Okay. As Claude told, and I told you earlier, the series of webinars on the ISOP, International Society of Proton Therapy, the first one happened today. The next one is on 21st, the same time, next Wednesday on 21st, with the Apollo Proton Cancer team with Dr. Rakesh Jalali and Dr. Dayanand Sharma. So it will be a talk on their clinical experience of the first 200 cases, what they've done so far. And so looking forward to most of you joining us next week and get enlightened with the proton therapy live reality in India. Thank you very much. Thank you, Dr. Lasker, again for your nice talk, and Claudia for your technical update. Thank you. Thank you, one and all.
Thank you.
Thank you, all of you, for taking your time and logging into the session. Some of you may be too early in LATAM, but I think I really appreciate your taking your time and joining the session. I hope this session was informative, and we will promise to continue to do many more sessions in future, thanks to COVID, using the webinar module. Thank you.
Thank you.
Thank you.
Very
Goodbye.
much. Bye-bye. Bye, Claude.
Bye-bye.
Bye, Dr.